The second part for the classes is about talking more about those methods, and this is what we are going to be talking about. In this lecture, the first part, we're going just to be talking about those two first topics. These more about methods, and then the new things that we're going to be seeing today is the method overloading, which is a very important concept in Java, and then you've been using it since the beginning, and then but you didn't realize that. We're going to make sure that you understand what it is and how to use it if we'd like to create our own overloaded methods. And this is a very interesting part of this object-oriented programming language of Java. Many other programming languages also allow this type of technique, but we're going to see that. After that, next meeting, we're going to be looking at those constructors and the equals to string methods. And let's start with the first things, the method invocation. So what we've seen so far is that we've seen like there are two types of methods: the method that returns something and methods that do not return anything. And we've been using for the first time last week, was it last week? Yes, the methods with arguments. When we put the declaration, we declare some variables between the parentheses of the method head. So we're going to be talking about those, and let's talk about these parameters and arguments. And this is the discussion that we're going to be starting. Yeah. So for example, if we have something like this, this is a method called met, and it returns a double, and it takes two arguments. The first one is an int, the second one is a double, and it returns the result of this operation. If I'm calling this method, let's imagine that this is a method that is part of some sort of a class, and then I declared an object which is from that class, and I'm calling this method using this. What I need to realize and make sure that when I'm calling a method, especially when it has many parameters, and just the arguments are going to the right place. And you can see now, for example, this 2 is an int, so it goes to the first part. I mean, the first part is a, it is an int, so it is expected to get an int, and this is what is happening here. The same thing for the 0.5, which is going to the second parameter, which is a double, and so this is a valid call of this method. But you have to be careful, because if you do something different, like this, for example, so the first one is okay, there's no problem, I'm sending in an int, but the second one has a problem. Yeah, we cannot convert implicitly the string ICS into a double, so this is going to give us a problem when we call this method. So when you call a method that has many arguments, you have just to be careful to send the information that you would like to send to that method according to what the method is expecting. So this method expects two values. The first one is an int and the second one is a double, and this is how we send those two values when we call the method. And then we just need to make sure that the data types are respected. So in this case, this is going to give us a problem because the second argument does not match the second parameter. There's some sort of a naming that I would like you to get from this, is that the value, we give it a name of argument. The variable that is going to hold that value, it is called parameter. So this is a parameter because when I'm talking about the variable that is going to hold that argument, which is the value that is sent. Okay, so you have to distinguish between the two. Argument is the value that is sent inside the method, and the parameter is the variable itself that will hold the value. Okay, So these are two important terms that you need to remember. Okay, what about this one? No, is it valid or invalid? Invalid? Why is that? The first one goes to the first argument goes to the first parameter, but then we have a problem. It is going to be converted to 0. Is it going to be converted to 0? Or is it going to be giving me an error? Well, those who said it's valid are wrong. It is not going to convert to 0. Because remember, we can convert from a smaller data type to a bigger data type. From int, for example, if I declare something like double. Okay, let's get into this. Right, double D equal 2. 2 is an int, of course, because I did not use 2.0. So this is an int that I'm going to put inside of a double, a small value into a big cup. That's fine. But a big value into a smaller cup, that's not possible. Okay? That's why this is not going to be possible. So this is going to give you an invalid, this is in an invalid call, and it's going to give you an error because the order did not match. So you have to not only give like the arguments, the data types that are requested, but you have to give them in the correct order as well. So you have to pay attention to that. Yes? Excuse me? Okay, if both of them are double, still the same thing. The problem is that this is going to create a problem because we cannot convert implicitly a double to an int. This is a double. Can you put a double inside of an int? No. Oh, okay, sorry. Now, if your question was, if this was double, and this is a good question, if this was double A and double B, will this be an invalid call? It will be valid. The first one is a double going to a double, that's natural. The second one is an int going into a double, that's not a problem. Because it's a small value that can be held in that big container. Okay? So that's not a problem. Fine. What about this one over here? It is valid. Look, I'm giving an int as the first argument and a double as the second argument. And I have an int in the first argument and a double in the second. So does it look good? Yes, but this is a problem. Since you added this third argument, there is no third parameter to hold that third argument, and then hence this is going to give you an error message. The compiler is not going to be accepting that because, sorry, what am I doing with this 3 that you gave me? I have no idea, so I'm going to stop right there. So very important also, we said like the number of arguments is important, the order is important, and obviously we said the number of arguments is important. The data type as well is important. Okay, so this is we've been talking about the fact that if they were like a smaller data type, parameters are automatically typecasted, which is converted to the according. So this is valid even if the second one, is an int, but it is going to be automatically converted to double. So this is what we were talking about. So is that clear? The second part is about talking about this return value that we are going to be returning, like this return here that is there. We said for all non-void methods, we need to have a return inside of that method. If I'm using a void, I don't have to use a return. And I'm not saying I cannot use. I'm saying I don't have to. And maybe later on I'm going to show you, bi'idhnillah, some examples where a void can have also return, and then what does it mean, and we're going to talk about it. But the main thing that I would like you to remember is that any non-void method, which is any method that has any data type, either it's a primitive data type like int, double, float, short, byte, boolean, or a class data type like string. I can have a method that returns a scanner, whatever. You just think about it. You can put whatever class you can have, you can put it as a return data type. Then if you have a non-void method, you have to put a return. You have to. And this is the main thing that we would like to make you realize. And also what we return, not only that we need to see this keyword, but we need to send the right data type as well. So I cannot send a string, for example, here while I'm saying I'm going to return a double. So you have to be careful when you have a non-void method to always have the return keyword somewhere in your method body, in the body of your method, and then you need to return something of the same data type of this double. So now my question, is this a double? Yeah. A is an int and B a double. So I'm involving an int and a double in some sort of operations, and the result is going to be double. Okay. If I do something like this, there's going to be an error message. Which one? There's no return in this method. I'm not returning anything. I'm doing some calculation. I'm saving the result of that calculation in R, but I'm not returning it. So this is going to be a problem. If I'd like to fix this, what should I do? I can just have to do return, for example, leave this as it is, and then return R, or just make this as it was before, return right here, and then have the return. Well, I'm not very good at writing with the mouse. Return, yeah, which is quite shorter than straightforward. This is like you have take the result, save it somewhere, and then this somewhere, whatever it's inside of it, return it. While with the other one, you just calculate the result of that calculation, send it, return it. Yes. This one, if I add the return, yes, it is going to solve the problem. But is it going to make a big difference? Well, not that much. Yeah. This is just to make you realize that you have to have the return statement inside of the method. That's the thing. Regarding the void methods, so return methods, as I told you, methods that return something else than void are methods that are generally going to be used like some sort of a mathematical function that returns a result, and that result is a value that I can use either to store it in a variable, or to display it on the screen, or to do whatever I would like to be doing with that as of any value that I have in my program. With the void methods, however, I cannot consider this result as a value, because this is just a group of statements, a statement that are grouped together and then executed when I call them. And generally, inside of those void methods, we can use them to display things, perform some operations that do not require to return any value. And for example, in this case, you can have like this show menu that will always display these 4 lines, and that's it. And it says that the void method does not require. It doesn't mean that does not allow to have a return statement. And let me show you maybe just quickly what would happen if I have like in the middle between these two. Let me just erase all of it. Imagine if in the middle between those statements I have return 5. Okay, first of all, this return 5 is not acceptable, because we said I'm returning nothing, and I'm saying, oh, I'm returning 5. This is an int. So now it's going to tell me, well, you have a problem. You said you're returning nothing and then you return something. Well, that's not always the case. Actually, return is going to return something. Sometimes when you do return like this, it's like the break. You remember the break for the loops? What break does for loops, return does it for methods. If you have a return somewhere in the middle of your method, then it is going to stop right there and exit the method. So this is the idea. So I can use, in some ways, in some cases, a return into a void method. Sorry, I can use a return in a void method, but in this case, I will want the program. I mean the execution, the statements to be executed up to the return statement, and then we exit that method to go to do something else. So anyway, this is another discussion. We're going to throw details about what happens if I return value into a void method. We're going to test that and see it running by ourselves. Well, this is an example. For example, when I'm returning something that is nothing. Actually, I'm just returning without any value. That means just stop the execution of this method. So for example, if the length, the first name dot length is equal to 0, or the last name dot length is equal to 0, it is going to display incorrect name and stop, get out and stop. That means this is not going to be displayed on the screen because I will never reach it in the case where one of them is empty. If none of them are empty, then I'm not going to get inside of the if, and I'm going to execute whatever it's in here. You remember the char at? What does it do? Get a letter at a specific position from the string that is attached to. So in this case, fn.char 0, it is going to give me the first letter of the first name, and the second, it will add it to the second letter, to the first letter of the last name. So this is why they call it show initials. It is just going to show the first letters of your first name and last name next to each other. Is it clear? Do you have any questions? Returns means like the break. You remember when we've seen the break in the loop statements? So what does the break do? Stop the execution of the stop the looping and get out of the loop. This return does the same thing. If I reach it, I'm going to stop the execution and get out of the method. Yes. If I didn't write the return, then in all cases, regardless if this is empty or not, I'm going to display, if it's empty, incorrect name, and then display as well this sort of a thing. But remember, this is empty. So what would this char at 0 will give me? There's no first letter because it says this is empty. There's no letter at all in one of them maybe. So this is going to give you some exception, probably. Your question? Same thing? All right? Okay, let's talk about some other things. In some methods, I might have to declare some variables inside of them because I would like to be doing something like the double R, A divided by B that we've seen before, or like these ones over here. Look what is going to happen in this one. This do something is declaring two variables A and B, and then put in those A and B into as an argument of this AVG, which is another method that takes two numbers and it displays, what is that? Which is the average. It doesn't return the average, it just displays it on the screen. It calculates the first one plus the second one divided by 2.0, and the 0.0 is very important because if I didn't do it, the result would be an int, so it is not going to be very accurate. So the thing that we would like you to realize here is I'm using A and B and again A and B. Even though the names are the same, first of all, this is allowed because the scope of each one of them. You remember the scope of a variable? What is the scope of a variable? What is the scope of a variable again? Well, yes, these are the types of variables. Depending on where they are declared, they have some specific names. But what is the scope of a variable? Have you ever heard about that term, scope?
But it's not.
Very good. Where it is known. The place, the part of the code where your variable is known, this is called scope of that variable. And if I'm declaring something between those two braces, this is the scope of your variable. So this A and B is known only here. That means outside of this block, the A, B is not, those ones at least, are not known. But if I'm declaring some other ones that have the same name, that's allowed. That's no problem. That's not a problem. So what is going to happen here? I'm putting 10 inside of A. So this is exactly as if I'm calling with 10 and 20. So this 10 is going to be in this other A and this 20 in this other B. So now A is 10 plus 20, 30. 30 divided by 2. So that's 15. What am I doing with this 15? And I put 15.0 because of a double. I'm going to display it on the screen and go back to the line. When I'm sending some values inside of the methods, I mean there are two types of ways those values, this process is happening. There's a way when we call it, this is called by value because I'm sending only the value. But sometimes, depending on the data type of my variables or the structure of my variable that I'm sending, I might be sending them by reference. So we have like call by value and call by reference. Let me clear this out just by showing you in this example. Take a minute and look at this example and tell me what should I see on the screen. So am I going to see, so one answer is A equal 10. And then A equal 12? Twice? Everybody agrees? 10, 10, 22. So there's another option. Somebody else says 10, 10, 22. Yes? 10, 10, 12. 10, 10, 12. 10, 12, 10. MashaAllah. Any other options? Any other answers? Well, that's great. I mean, at least you tried something. But one of them is the right answer, and this is the one. Which I meant this is to be 10, 10, and then 12. No, no. Because there's nothing that tells us where the A is declared except it's here. So let's follow our variables and see what is going to be happening to them. Okay? Splash your face with some water. Maybe it can help. It might help. Okay. So I'm putting into this A 10. Okay. And now I'm going to display A equal 10. Everybody agrees on this one, except maybe some who said 12 at the beginning. Well, the first one is going to be displaying something, is this statement over here. Now I need to execute this one, increment by 2, and inside of this I'm sending A inside of this increment by 2. So this A over here is another A, not the same, because this is part of a parameter which is declared as a parameter, so it is known only in this block in the body of this method. So I have another A, and in that A that was 10, now that 10 I'm adding 2 to it, so it's going to be 12, and I'm going to display A equal 12. And now I need you to realize what is going to happen. Now when I'm leaving this one to go back to here to continue, this A over here is lost, deleted from the memory. So when I'm displaying what is inside of A, it is going to be 10. Why? Because that was the 10 that was there before. Because we did not finish. Okay, this is a good question. True, there's no loop in here. I arrived here. Okay, I have to execute all these lines, right? All these statements need to be executed one by one. So I executed this one. I put 10 inside of A. By executing this one, I displayed A equal 10. When I'm executing this one, what would happen? I need to go inside and display. Yeah, and see what's going to happen. So that's why I went inside. I did whatever. I executed all this. The first one, put 2 into A. That became 12. Displayed A equal 12. Then I need to come back and continue. I haven't finished here, so I need now to continue and execute the last statement, and then I'm done. This was not a loop. I just went inside, do whatever I needed to be doing, and then get back and continue where I left. So this is what we mean by call by value. When I sent A inside the other method, I didn't send the variable itself to be changed. I just took a copy of the value, sent it inside, and then the other copy is still there. This is what we call the call by value. And this is always happening when your parameter is of a primitive data type, which means int, double, float, boolean, short, char, or any of those. What happens if it's not a primitive data type? Then, if it is not a primitive data type, this is what we call the call by reference. So all for non-primitive data types like string, any other data type, scanner, student, table, whatever you think about, whatever class you have, and then if you send something as a parameter, then you're sending not only the value, you're sending the whole variable. It's the whole variable that gets inside, which means, like, for example, let's have a look at this simple example. If I'm doing something like this, do something. I declared some class, this is my object from that class, and then I send that object as an argument to this method over here, which takes as a parameter my class, which is the same data type of this one over here, and I named it B here. So now if I do some b.setValue 5, I'm going to put something inside of that one of the variables of that object. So it is going to change, because now what I did when I declared my object, this is my object of the type my class, and imagine that this value was 0 at the beginning. Now if I'm sending it, I'm calling setValue. Actually what I did, this is going to be sent inside and known as B. So now B is pointing at the same place as my object, which is not two different values. It's the same place in the memory, the same box that I'm sending. I have like two names, two pointers that points to it. Now with this B, if I do the set value, it is going to change that value there. So even if I get out and do something like display the value of my object, it is going to be 5, because this is the new updated one. This is what we mean with this call by reference. Okay, so just to simplify things, if I had to give you just a very simplified answer to the definition of this call by value. Call by value, I'm sending only the value, not the variable, the container. I'm just sending the value. I'm keeping a copy. And this is always happening when I'm sending primitive data types, int, long, float, double, etc. When I'm using some class data types or arrays, if I'm sending arrays, even arrays of ints, or arrays of doubles, arrays of primitive data types, also are going to be considered to be called by reference. That means I'm sending the whole variable, and this means it can be changed. All the values can be changed. If I change something inside my method, the change will be retained, even outside of that method. Was I clear enough? Nobody said yes. Examples? Well, besides that example, I don't have many of those, but maybe in the book you can have later on, and maybe some later on we can do some exercises that are related to this. But first of all, I just would like to just do one last thing, and then maybe take some time for some exercises if we have some time left, I mean. Okay, now let's have a look at this. This is the first part about the methods. So we just talk about this just to give you some more information about how to deal with methods. And then there were like two types of calls: called by values, called by reference. And we've seen that there are also some things that I need to take care of when I'm using and sending some arguments inside my parameters, which is the data type, the order, and the number of those arguments need to be matched by whatever it's in the method's definition. Now let's talk about this something else which is called method overloading. This is a very important concept, and you have to just get this right. It's very simple to understand, but just sometimes you might need to remember those small things. So in order to explain this method overloading, I need you to realize that there's another name that I would like you to understand, which is called the method signature. What is the method signature? Just maybe a scary word for saying this is the method signature. The name of the method and how many parameters and what are their data types and what are their order. This is the method signature. So the signature of this one is this. The signature of that one is that, which is just this is the output details that takes no parameters. That has no parameters. All right? Now, the method overloading means I can have many methods with the same name, but a different signature. Many methods with the same name, but a different signature. Let me try to simplify this. Can I have two methods called setName? Well, if he said yes, no, I just would like to have exactly the same name, like this one, for example. Instead of output details, I will call it setName, just like this, with just two parentheses and nothing inside of it. It's okay because they do not have the same signature. What happens if I have like two methods, both of them have the same signature? Or maybe A, let's name it A, it doesn't have to be. I'm calling A, for example. This is not possible because they have the same they have the same name. That's fine, because we can have the two methods with the same name, but they should not have the same signature. But those two methods now, they have the same signature because both of them, they take only one argument and the same data type. It's both of them are string. If you are the compiler and you have two methods with the same name and both of them, they take a string, only one, how will you distinguish between, if I tell you this dot set name, which one are you going to execute, this one or that one? So the compiler needs to have something to differentiate between the two methods, even if they have the same name. So how we can differentiate between those by looking at this signature, which is how many arguments, how many parameters do I have? What are their data types? And what are their order? So we can have like the same data types, the same number, but different order. And we're going to see some examples just right away. For example, something like this. So this is permissible because even if they have the same name, but they don't have the same signature, because one takes a string as an argument, the other one takes nothing. So the compiler, he can distinguish between those two. So no problems. But I cannot, for example, I cannot have something like set name without anything, and another one set name without anything, and both of them are going to be together? No, it's impossible, because the compiler cannot distinguish between those two. It is going to be ambiguous to the compiler, and the compiler is not going to take any decision on your behalf. So it's going just to tell you, stop, I cannot do this, I have no idea which one I'm going to be calling, so fix that. So either you change the name of one, or maybe add some other parameters. So we've been using method overloading since a long time. You remember this substring? Let me maybe show you something even more interesting. If this is going to be working, discard. Yeah, just let's start this NetBeans while we're talking, because I'm going to show you some other examples of, especially one that you've been using since the beginning, and it is an overloaded method. Do you have an idea which one I'm talking about? Do you remember I've been using an overloaded method? Which one? Index? No, index is just a name of a variable. Which one? Substring? What do you mean? Yeah, what this does, it just extracts. In this case, what does it do? S.substring 2. So what would be the result? I have S instead of S, Java. V or VA? This one is going to show me VA. Because if you give only one position for the substring, it is going to tell you this is where I start, and I'm not ending until I reach the end of the string. That's why it's going to see VA. If I'm using this one though, substring 0, 2, that's 0, that's 1, that's 2. So I'm starting with the first one, I'm not including the last one, so I'm going to stop at the A here. So JA, Java for that one. Okay? Let me show you, I think NetBeans has loaded. Let me show you something, whatever this one is. What about this one over here? This print line. I have print line that takes a string, right? But I have a print line that takes a char, an array of chars. I have a print line that takes a double, a print line that takes a float, a print line that takes a long. Whatever you give it to it is going to work. If I'm using, for example, something like this, 5. This is an int. It is going to work. Okay? This is a text. It is still going to work, because this is an overloaded method. I can use it with various situations, depending on how I programmed it. So they programmed this system.out.println to be really flexible. Whatever you give it to it is going to display it to you on the screen. So this is one of the advantages of this overloading. It gives you the ability to have the same name, but then you can use it differently according to your needs. There's only one condition though, to have two methods or more methods with the same name, is that they should have a different signature. And what is the signature of a method? It is the name of the method. The parameters, how many are they? How many parameters we have? What are their data types? And the last thing, the third one, what is the order of those data types? Because I can have something, for example, Yeah, I can have two ints. No, one int, one double. I don't know. I just would like to use this as an example. I don't know, doesn't make sense. Let's have like public void. I have method, and then I'm going to use int a and let's say double b. And then I have something, whatever inside. And then I have another method. You see, if I copied and pasted the same thing, it's going to tell me method is already method, and then between parentheses I see an int. An int and a double is already defined in class rectangle, because I already have a method with that signature. Now if I change that by putting, for example, double, one of them is different, that's fine. The order now is different, that's also fine. So they have the same number of arguments, they have the same data types in the terms of parameters, but not in the same order. So the order is also important. Sorry? Okay, now you're talking. This is a good question. What would happen if I have exactly the same method, but this time in another class? Not in the same class, but let's say in this class over there. Over here. Let's say I have in this class, I'm having a method. Is this a problem? No. It's like a variable. I'm declaring it at the same, not at the same place. If you do display what? Well, if you'd like to display this method, what you would like to display depends on what you would like it to be doing. What do you want it to be displaying? A plus B, or A divided by B, or just A and B? A equal and then A and then whatever. It's up to you. It's you that decide what is the behavior of that method. What is the action that is going to be done by this method. I'm just talking about the general fact. If you'd like to have two methods with the same name, you have just to be careful that they should not have the same signature. And this is called this has a name in object-oriented programming languages. This is called method overloading. Method overloading. Where was I? Yeah. Okay, let's have some small examples. Okay, have a look at this. So we have this sample class and then this test class that is instantiating this sample class. This object is from this data type. So have a look at this. When I'm using this do something, which do something am I calling? This one over here. How did you know that? I'm calling the first one. Why? What is, yes, so that's a good point. You check the data type of A, which was an int, and B, same thing, it's an int. And which one is int and int? So the first one is more, the second one can be accepted, can accept that one as well, right? But since the two are int, int, and we have an int, int, so we're going to send this to that one. Okay? What about the second one over here? No, because it's the same data type. Not because it's the first. Very important. Even if this one was shuffled and this is the last one, it doesn't matter. It is going to find this one with the same signature. I'm calling do something with int and int, and there's one do something with int and int. That's why we're calling it. Not because it's the first one, but because it has the same signature or a compatible signature. We're going to see maybe some examples. What about D and E? We said D is double, E is double, so we have a double double. That's the word second. Okay, what about then the third one? Well, in this case there's no doubt because all of them are 3, but I have to make sure that are these all ints? Yes, so that's fine. It's going to be the third one. Okay, now let's have some more trickier questions. What about this over here? So I have two in this sample class. I have one increase with an int and one increase with a double. When I'm calling this one, it is going for the first one because obviously int is a is an int, so it's going to go for the int. And D is a double, it is going to go for the double, right? What happens if I'm calling now with this? This is valid because it's going to take the first one. Very good. Very simple. Second one.
Valid the second one. The second one.
First of all, is it valid or invalid?
Valid.
Who said valid? Who said invalid? And those who abstain, what do they say? Neither valid nor invalid.
The second one.
Okay, let's. This is both of them are int, right? And we don't have two ints. But do we have something that can accept an int without creating a problem? If I put the 5 in a double, it will not hurt. And the 10 in a y in the int, that's fine because it's an int already. So this is possible. So this is not invalid. So it is valid, actually. But hey, what would happen? I have also int as a first one, and 10 also can be put in a double, the second one. So now the compiler has two options, and whenever the compiler has options, he stops. Which one should I execute? I have no idea, so I need just to write this is an error, this is a mistake. There's a mistake somewhere. So very important, even though we make sure that we respect the order, we respect the data types, we need to pay attention that we avoid having some ambiguities that will make the compiler not understand which one is going to be called. Yes. Why it's invalid? Okay, if you look here, I can potentially put this 5 in here, right? Yeah. And this 10 in a double, which is okay, because a small value in a big cup, that's fine. But the problem is, I can also put this 5 into this double, which is okay, small value in a big cup, still the same thing, and this one over here. So now this can be called either by this one or that one, and which one is going to be selected? So the compiler will not decide for you, so you have to decide for yourself. So that's why, and this is the ambiguity comes because these two cases are quite ambiguous in this case, in this scenario. So you have to decide yourself. For example, you choose one of them to be a double. So now it's clear. Oh, I know, because one is 10.0, so this is going to be here, and the other one is acceptable there, so this is going to be there. This is how you can manage this ambiguity. No. It checks all the methods. Yes, that's why when we define our classes, we don't have to put some sort of order. You can define them in any order that you want. They just have to be there. They don't have to be the first, the second. If this is the first, it has a meaning. No, there's no meaning of that. Okay, so that's the thing. That's what I wanted to talk about it for today. I'm going to go for some exercises. So do you have any questions before you go in the exercises part? So we've seen, just to summarize, we've seen that methods in their signature, they can have different parameters, and the values that we put inside the parameters, they are called? No, the values that we put in the parameters are called arguments. Values are arguments, and the variables are called parameters because these are special variables that allow us to send some values inside of the method to work with the values inside of that method. We have like two types of methods. We said method that returns something, method that returns nothing. If we return something, we should have the return keyword. And we should also return the same data type. The other part, when we're talking about the signature, method signature, we can have different methods with the same name and different signature. This is called overloading. No, different methods with with different signatures. Sorry, same methods names. Methods with the same name. I have to just to get my wording right, because if I just say something differently, it might not be accurate. So different methods with the same name and different signatures, they are called overloaded methods.